Hello friends, how are you? Hope now we are in the final phase of the topics of class 12, that is this electronics, semiconductors, that chapter we started some time back. So hope you are enjoying these topics, and these are very simple topics. Most important, recently conducted JEE mains exam. It contains questions from this topic. Those were very simple questions, free of cost, 4 marks. Fine. So this chapter, apart from advanced exam, JEE advanced exam, this chapter is important for all other exams. Okay. So that's why repeatedly I am requesting you that please try to revise these topics, and the way we are explaining, just try to understand in simple manners. Fine. So today we are starting a new phase of this particular chapter, that is obviously part of this chapter, that is digital circuit. Fine. Basically students, this digital circuit, you may say, is just a drop of the ocean which is known as digital electronics. So digital electronics is ocean, and digital circuits is just a small drop of that. I mean, if few of you when qualify for IITs and other good institutes, and would you like to join like your computer science, electronics, telecommunication and so on and so forth, then in depth you have to study this digital electronics. But nowadays, fine, literate or illiterate, I mean people in India, all are very much comfortable with the use of mobile phone, basic features of laptops, LED TVs, all these things, and these devices essentially are solid state electronics devices. So they comes under the category of digital circuits. Fine. Now let's start this discussion about digital circuits. Before digital circuits, the maximum utilization was analog circuit. So you can say there are two types of circuits. Fine. That is, there are two types of circuits. One is analog circuit. Fine. Analog circuit. And another is digital circuit. Fine. So what exactly the basic difference in analog and digital? See, for analog circuit, the variation in potential, I mean voltage or current, it can take any value. So if on a graph response you can plot this analog circuit, then the response may be like anything like this. Fine. Any of these type of any values it can take. So this is analog circuit where fluctuations are allowed. Okay. Let's say the response of a digital circuit. Now this was analog, where fluctuation or variation of voltage or current can take place. Now the digital circuit is, it loves to talk in black and white, 0 or 1, true or false, low or high, nothing in between, either yes or no, that's it. Nothing like in between yes, in between no. Fine. So it is going to be like this way. So if it is time and it is any signal, let's say for example, then you will get the values in this fashion. And if I use a different color, then this is going to be low or false or 0, cut, something like that. And this entire portion is known as yes or high or 1, something like that, these bars. Fine. So digital circuit has only discrete values, either 1, either 0, either high, either low. So this is the first difference of these two types of circuits. Now Why in digital circuits these all logics are used, only semiconductors are used? So there are various reasons, fine, and we just want to confine our discussion from this digital circuits point of view. So what I'll do, I'll mention few important points about digital circuits. Why digital circuits are so much used, why digital circuits are cheap, why digital circuits are so efficient, reliable, all these aspects, fine. So in small terms I will mention these. First is, you can say important points, fine. So number one, you can say uses, important points of digital circuits, fine, important points of digital circuits. So number one, you can say uses discrete values, fine, uses discrete values, discrete, DIS, uses discrete values. That is one aspect. Discrete means either low, either high, nothing in between, fine. Then second point you can mention these are, I mean digital circuits, these are much faster and reliable, and one more thing I would like to mention to all of you, I mean all those who are watching this video or other videos, whatever we discussed in various chapters in our these videos, recently in this IIT JEE mains exam that is conducted by CBSE board, many questions you can say up to some extent directly from those topics that we discussed. Specifically I mentioned those things, fine. So if you just analyze this question paper and analyze our video, say for example one question was from polarization, and the concept of polarization in depth I discussed, and I devoted good amount of time on this particular concept of I is equal to I naught cos square theta type of formula. So the direct question was there, fine. So if I am devoting much time on any topic, I am explaining anything, you just take it very seriously, fine. And if you just want to verify my statement, look these videos, take your paper, and you will directly find the answers. So these are much faster and reliable. Reason being, why they are so reliable and much faster. So for that, if you try to recall that during the discussion of the semiconductor devices, transistors, TTL, transistor logic, diode logic, we discussed those things. One example I would like to mention over here, I'm sure, I mean not you, but your parents must have used, even I don't know how to use that mobile, that telephone, basic landline phone, where there was no keypad to type the numbers. It was a circular dial, and you have to put your finger in one number and turn it and then remove it. So it was not reliable, fine. Normally dialing the number using that phone is not easy or not accurate. Second point is, it took lot of time because it generates voltage according to that dialing, 1, then 2, then 3, and so on. But now consider the situation, even in mobile phone no keypad, only the image of the keypad, and put 1 2 3 4 5 6 ABCD and so on, fine. Earlier mobile phone, some 5-6 years back when I was in IIT Delhi, I purchased one phone that was keys, but now there is changes are like that. So these digital circuits are much faster and reliable, fine. As there is no point of mentioning, as simply say they operates in binary. Binary means 2, in binary fashion, manner, process, fine. Here fashion means not jeans t-shirt, but fashion means manners, fashion, fine. So term I mentioned as yn. Yn means yes, no, or 2t, true, false, f, or 0, 1, something like that. Fine. So these they operates, or they love to talk, they respond in binary fashion. Fine. It is meaningless to mention no other value between 0, 1. This 0, 1 is not 0.1, 0.5, 0. Nothing like that. No value between 0 to 1 is allowed. Fine. So this is the particular mention of the binary fashion in which these digital circuits operate. Now one more point. Actually students, there are two logics, fine, in digital electronics. One is positive logic, another is negative logic. So simply I would like to mention over here, there are two types of logic. One is positive logic, fine. Another is negative logic, fine. Positive logic means high means 1, true means 1, and 0 means low or false. But in negative logic, it is just reverse of positive logic. Negative logic means high means 0, true means 0, correct means 0. So we follow positive logic. Negative logic is also important, but it is not for us. We are going to discuss the entire concept starting from the phenomena of positive logic. Even logic circuits, logic gates, NOR gate, OR gate, AND gate, NAND gate, all these gates, we apply positive logic. Fine. So the entire discussion is going on keeping this point in mind. So now we would like to come on to the next phase of this discussion, that is, you can ask a question, how we can implement these logic operations. Fine. So let me mention it. Digital, this is a point I am mentioning, digital circuit contain diodes. For example, try to recall, in one of my previous lectures I mentioned PN junction diode, its applications, fine, diodes or transistors. Transistors are nothing but they are essentially combination of diodes plus diodes and so on, fine, transistors. So digital circuit contain diodes or transistors as switches. Now what is the meaning of this as switches? Is it like that you can use these diodes or transistors as circuit switches? It means, let us say the room in which you are sitting and watching this video. Obviously in that room one switch may be for fan, tube light, another switch you may say one big switch for the power supply for your air conditioner, fridge and all these. So there are two possibility for a switch, normal switch, fine, you forget about digital electronics and all these things. Let us say you want to switch off your fan because you are feeling slightly cold. So what you will have to do, you will have to just push the switch in one specific direction. So there are only two values possible for a fan, for a tube light, for a AC switch, either on or off. So same is the situation. Diodes, forward bias, try to recall, forward biasing it will work, reverse biasing no working. So again when it is going to be forward bias, half forward bias, then half wave rectifier. In a p-type semiconductor, the acceptor level is situated 60 milli-electron volt above the valence band. Okay. The maximum wavelength of light required to produce a hole will be how much? First thing, this question is framed using the phenomena of semiconductors, but what exactly the idea and which type of formula you can apply, that I would like to explain you. So, the idea over here is, let us say we want to give a simple diagram to this particular question. What is mentioned? Above the valence band, fine. So, let us say this is valence band VB, above it there is a 60 milli-electron volt energy gap, fine, and then acceptor level. Okay. So, basically energy gap is given, that is 60 into 10 to the power minus 3 electron volt, fine. We can convert it in joule by multiplying it with 1.6 into 10 to the power minus 19 coulomb. We are supposed to find out the wavelength associated with this particular energy value, fine. So, now you can say this question is simple, and the formula that you learned in photoelectric effect, that you can apply over here very easily. And what is that formula? That formula is E is equal to Hc over lambda. The value of H is 6.63 into 10 to the power minus 34, C is 3 into 10 to the power 8 meter per second, lambda value you have to find, and E value is 60 into 10 to the power minus 3 into 1.6 into 10 to the power minus 19 coulomb. What exactly the point of putting this question? Formula is simple, concept is simple. The only problematic part is calculation. Calculation is simple, but so long just because of these numbers that in general if you are not extra careful, you will commit mistake. Then if you just take a look of the options, they are same, just simple this you can say difference in the placement of the decimal point. So, a small amount of mistake in calculation ultimately give you a problem. These type of questions are asked just to kill your precious time, or they want to check how comfortable you are in calculation so that you can manage the time in the examination hall. My simple suggestion for this particular question is, listen carefully, some fast calculations that you have to practice. No scope for that because no calculator, no device is allowed even to carry inside the examination center. Forget about examination hall, fine. No mobile, no pager, no calculator, nothing. Even in JEE main exam, you cannot carry your own pen or pencil. They have to provide, they will provide, they provides, fine. Only admit card. So, calculation practice, and few terms you can remember. What are those few terms? Say for example, H into C is a value which is in general you used in your modern physics in these type of examples. So, better 6.63 10 to the power minus 34 multiplied by 3 into 10 to the power 8. Remember that value, that final result after these two multiplication. So, that will save lot of time, fine. Now, ultimately after this much sermon, let me mention the exact solution of this problem. That is just one or two steps I will mention because it is my duty ultimately to explain which one is the correct option, fine. So, what I will mention, let me allow to use this space. Using E is equal to Hc upon lambda, lambda is equal to 2.07 into 10 to the power minus 5 meter. Simply multiply, divide and get the resultant. So, from here you can say B is the correct option, okay. So the first question you can say it's a less question, more a suggestion. Fine. Now here comes a second question. Resistivity of semiconductor depends on. These type of questions you are bound to get in examination hall, and as such no specific preparation is required. Your normal understanding of the topic is more than enough. Let us say I don't know anything, fine, but what I will do, I will start reading one by one these options. Accordingly we will try to find out the correct option. First, resistivity depends, it means conductivity, opposite of that. How better a conductor is semiconductor. How better a conductor is a semiconductor means if you have 3-4 semiconductors, which one is better semiconductor, I mean best conduct. So that way you have to define this. First is shape of semiconductor. Shape means circular, triangular, rectangular, elliptical. Is it like that? These aspects are important for the resistivity? No, not at all. So it means first shape is meaningless, it is not correct. Next, atomic nature of semiconductor. Let us say I have silicon, I have germanium, both have 4 electrons in outermost cell, but valence band, conduction band gapping is different, reverse voltage is different. So yes, atomic nature of semiconductor, it may be one correct option. Still I am not saying it is correct option, it may be, fine. Let us move for C, because in these type of competitive exams where negative marking is also there, unless and until you are not 200% sure, never mark your response. First, meaningless, no need to think. Second, may be possible, but let me check other options. Okay. Length of semiconductor. Length means what? Again shape. Because we discarded shape, so length or any physical parameter, no role. Fine. Fourth one. Shape and atomic nature. But atomic nature is okay. Again shape. So atomic nature alone is sufficient to decide resistivity of semiconductor. Shape, physical parameters like length, width, height, nothing is important. So now without knowing anything, just on the basis of logical conclusions, you can say B is the correct option. Fine. So this is the approach, because you don't know which question will come in examination. Ultimately you have to inculcate an habit where you can kill the question. Kill the question means solve the problem properly. Okay. Let us move ahead. If you will not kill the question will do something wrong to you. Okay. In a half wave rectifier, now here please wait. Actually in these two previous questions, I started my discussion with the basic structure of a semiconductor, where I talked about valence band, energy gap, conduction band. In second question, what I explained you, again it was associated with the, you can say, microscopic property. But here I created a device. Once I created a PN diode, PN junction diode. Now that microscopic behavior, it means we have the clarity. So here we are going to use this device, half wave rectifier, one PN diode. The RMS value of AC component of the wave is RMS value of AC component. It means two types of components are possible. Basically what half wave rectifier is doing, you are providing AC, and half wave rectifier is converting half cycle of AC into DC, remaining half not available because it is half wave rectifier. If you attach two rectifiers, two diodes, and create a full wave rectifier circuit, as I explained you during the discussion of these topics in regular shoots, So that will give you complete DC. Half wave rectifier means for half cycle of AC DC, then no response, then again DC, then no response, and so on. Fine. So in half wave rectifier, RMS value of AC, fine, component of wave is equal to, more than, or less than. Obviously my half wave rectifier is providing me DC output, and what about its value vis-a-vis AC component, that we exactly want to find out. Now there are various type of losses and all these things, ripple factor and all this, which we explained properly. So I hope you have that idea, because you are regularly watching these videos. So here we can say RMS value of AC is more than DC value. You will say why? Okay, so first I will write down why. RMS value of AC is more than DC because of barrier voltage, this is something which just to explain you, fine, DC because of barrier voltage fine, because of barrier voltage of PN junction, JUNCTION, barrier junction. So RMS value of AC is more than DC because of barrier voltage of PN junction. So now more than required, I explained, because barrier voltage PN junction, fine. This is a very simple explanation. So these questions you can say not difficult, fine. But just they want to check how much you are comfortable with your basics.